So, good afternoon. Let's get started with this session. So first of all, let's make sure everyone is in the right room. This is NET403. It is a deep dive session. It is about Direct Connect and VPNs. My name is Steve Seymour. I am a Principal Solutions Architect with AWS, and I've been delivering variations on this session for the last couple of years. Now, this is a 400-level session. So I'm expecting that the people that are listening to this are deeply familiar with these topics already. So you should be comfortable with how the technology around VPNs and Direct Connect works. The existing knowledge that perhaps you have came from maybe earlier this week in Gina's session, where she talked about connecting your VPCs and the various connectivity options that are available. Perhaps you were in Sid and Benjamin's session where they looked at hybrid connectivity, and again, they talked a lot in detail about Direct Connect and VPN. So overall, I'm expecting you to know the difference between an IPsec VPN and Direct Connect at the very beginning of this session. I also view this session now as what has become my annual opportunity to share the Queen's English with the rest of you. So this is what I consider a router, and this is what I consider a router. So just so we're clear on that at the very beginning of the session. Okay, so let's get started. So we're going to be talking about both VPN and Direct Connect, and we're going to be talking about all of these topics. So we're going to start with provisioning. We're going to look at the various options and configurations that are available for both services, and some of the updates that we've made to them over the last 12 months. We're going to explore how you deliver resilient connections using both VPN and Direct Connect, and then dive into a bit more detail around some of the announcements literally in the last couple of weeks. So global public virtual interfaces and Direct Connect gateway. So let's start with our managed VPN solution. So what is the AWS managed VPN? Well, as I say, I expect you to kind of already have the fundamentals here, but just as a bit of a reminder, this is a fully managed and highly available VPN solution. We provide termination points on the AWS end of the connection, and whenever you create a VPN connection into AWS, you actually are creating two tunnels. It is a site-to-site IPsec VPN. It supports a whole range of encryption options, and we do support NAT traversal. You pay per hour for that VPN connection to be available, and we support two different types of VPN, both static, policy-based, and dynamic, BGP-based. So a static VPN, what does that look like on AWS? Well, you've probably seen these in various other situations. You configure the VPN, you create all of the components in the AWS console, you create the virtual private gateway on one side of the connection, you define the customer gateway on the other side, and you create the VPN. Now, if it's a static VPN, you also have to tell us what IP addresses you're going to be using in your data center, what's behind the customer gateway. And from the VPC side, we're going to announce the side range for the VPC. Or rather, we're going to make it available over this VPN. Now, what this means is that we have to create security associations for these mappings of IP addresses. So there is one unique SA per tunnel, one inbound, one outbound. That means over 2 tunnels, we have 4 security associations. Now, that's fine if you can summarize all of your IP addressing in your data center or on premises as one nice CIDR range, but quite often that's not the case. So what do you do if you have multiple blocks of IPs that you use in your data center and that you want to be reachable over a static VPN connection? Well, you actually have to configure your end of the VPN to be 0/0.0.0.0/0, effectively any traffic. But now how do you enforce and control that traffic so that only certain addresses are actually reachable over this static VPN? So what you do here is you use ACLs on your router to cover the IP addresses that you want to be available over a static VPN. So effectively, you're filtering out anything that you don't want to flow over a static VPN. So whilst this is certainly possible, if you're going to be looking at complex configurations with VPN connections, perhaps combining with a Direct Connect, we're certainly going to recommend that you actually look at a dynamic VPN. So a dynamic VPN is where we use BGP within the IPsec tunnels to exchange routing information between the two ends of the connection. So the example you can see on the screen here, we've got our virtual private gateway on the left-hand side and the 2 endpoints that we provide for the VPN connection, connecting back to your customer gateway. Now, each tunnel has a defined pair of tunnel IP addresses, and we have to define an AS number. Now, BGP relies on ASs to identify the two ends of the BGP session, and then these two endpoints exchange that routing information. So you have to define these tunnel IP addresses. You have to define the AS number on the customer side of the connection and the AS number on the Amazon side of the connection. Also, you have to define a pre-shared key. Now, some of these can be automatically generated, but we also give you the option to define them yourself. So if we look at those inside tunnel IPs, for example, when you go to the VPN configuration screen, you'll see that you have the option to specify a CIDR that is used now for the inside tunnel IP addresses for this BGP session. These are 169.254 linked local addresses, but you can choose what they are rather than being automatically generated by us if you would like. You can also now choose the pre-shared key. So it can be between 8 and 64 characters in length, and you just fill it in on this screen. If you leave these fields blank, they're automatically generated. Now, I mentioned that you have to define the AS number for each end of the connection. On the customer side of that connection, you define that on the customer gateway. So you can use a public or private AS number. If you own a public AS and you want to use it, that's absolutely fine. Or you can define a private AS. But what about the Amazon side of this VPN connection? In the past, we've always defined that AS number for you. Well, now you can actually define that on the virtual private gateway when you create this. So by default, we will now assume 64512, or you can specify an AS that you want to use to represent the Amazon end of the connection, as long as it's a private AS. So why is a dynamic VPN something that we recommend when you have perhaps more complex situations, more connectivity? Well, let's look at a resilient configuration with a dynamic VPN. So in this situation, we actually have two customer gateways on the right-hand side of the screen, connecting to two VPCs on the left. You can see the different tunnels, so each of those VPN connections represented by two tunnels. And in this case, dynamic routing is going to make the configuration and the failover on your end of this connection much simpler. On our end of the connection, depending on what you're announcing over this BGP session, we can then fail over and use the most appropriate path. And I'm going to show you how our routing preferences work later on. So we have our VPN connection up and running, perhaps multiple VPN connections. How do we monitor this environment? Well, you can now do this using CloudWatch. So in CloudWatch, we now present 3 metrics for VPN. The tunnel state itself, so is the tunnel up, and we report a state of 1, or is it down? So now you can create alarms based on that tunnel state. We also give you the data in and data out. So you can monitor this, which is something previously you've had to do at your end of the connection. You can now see what we're seeing on the AWS side of that connection. All of this in the standard CloudWatch console. So how does billing work with VPN? Well, there are 2 components to billing on the VPN connection. First of all, there's the connection hours that I've mentioned already. When you create that VPN, we start charging you for that VPN connection. If you delete the VPN connection, that billing stops. The other element, though, is the data transfer. So how do we calculate that data transfer? Well, the simple answer is it depends on where the customer gateway is located for this VPN connection. So if this customer gateway is located in your data center and it is hosted out on a public IP out on the internet, then the rates that are applied are the internet data transfer rates, internet out. If, however, you're running this IPsec VPN perhaps over a direct connect over a public virtual interface, which is something that you can do, then actually we reduce the charge for the data transfer because we're carrying it over direct connect, so it's charged at direct connect rates. And then the final 2 scenarios that I'm showing on the screen there, what if the customer gateway happens to be some software instances that you're running perhaps in another VPC, accessing via its elastic IP address, or in another VPC in another region perhaps, and in which case we're charging the local data transfer rates to the region or the remote region data transfer rates. So the answer is it depends on where the customer gateway is located. Now, something else that is built into the virtual private gateway is VPN CloudHub. Now, it's not actually just about VPN connections. So what is CloudHub? Let's start with that. What CloudHub allows you to do is establish connections from your data centers or your on-premises infrastructure using a VPN or a Direct Connect private virtual interface into the virtual private gateway. What the virtual private gateway does is then takes all of the routes that it has learnt and re-advertises them back out to the other BGP peers. So it can become the hub in your connectivity if you so desire. Now, the example here shows 3 data centers on the right-hand side, all connecting to a single VPC, with the virtual private gateway, of course, in between. And you can see that the routes are being announced back out. Now, this feeds into how we actually built the transit VPC design. So if we actually swap out that top data center on the right-hand side and make it an AWS VPC, and we deploy 2 EC2 instances in there, we can build an IPsec VPN to the virtual private gateway. And now we're seeing the routes that are being received from those 2 data centers, as well as the VPC. So this is now established connectivity between some on-premises environments and 2 different AWS regions without having to create individual connections from your data centers to all of the regions. Now, the next step here is that you could, of course, deploy software VPN instances in multiple AWS VPCs in multiple regions and use the virtual private gateway to pass traffic between them. But after our announcement last night, I think I would just use the inter-region peering. So now you can build peering connections between 2 VPCs in different regions. The other scenario, though, just to add in here, is where you have a mix of VPN connections and Direct Connect. So you can see here we have a private virtual interface coming into this particular VPC, but a couple of remote offices, or perhaps AWS regions as shown here, all connected in over VPNs. And VPN CloudHub takes care of re-advertising the routes between all of these announcements. So VPN CloudHub is a really flexible tool, and it's very useful in certain situations. It's not something that you turn on or that you turn off. If you don't want to be using the routes that are advertised from VPN CloudHub, then you simply filter them out on your end of a connection. So with that, let's move on to Direct Connect. So on the Direct Connect side of things, what is Direct Connect? Well, first of all, it is clearly a dedicated private connection into AWS. You can create public and private virtual interfaces on Direct Connect, and as a result of having that connection straight into our network, you actually benefit from reduced data transfer rates. We're going to look at how this gives you consistent network performance and how you have options for redundancy with Direct Connect. So let's dive into some of the detail around this. But before we get into the configuration, I think it's always important to start at layer 1. So let's look at the physical connections. So these are all terms that you're probably familiar with. You know, people talk about things like Ethernet private lines, leased lines, even point-to-point circuits. These are all just connections that get you to a data center or to a facility where you can be cross-connected into AWS. If you're in the same building that we have a Direct Connect location, and we're now present in over 50 cities around the world, then actually this cross-connect is simply a piece of fiber that is run under the floor or on the cable trays in the data center, and it never has to leave the building. So it all depends where your equipment is located. So if you're in a data center, you might have some equipment like this, a couple of routers in a rack, and you're just going to order that cross-connect from the facility provider. That cross-connect is always a fiber connection, a single-mode fiber connection. It is 1,000 base LX or 10G base LR, depending on whether you're doing 1 gig or 10 gig connections. But if you are outside of that facility, then you may be working with a Direct Connect partner to establish that connection via that leased line, that pseudo wire, whatever service it is they offer that gets you into the Direct Connect location. Obviously, a key piece of this is that you need to have a router on your end of the connection that can terminate that single mode fiber and supports .1Q VLANs and supports BGP. So over Direct Connect, there is no option for static routing or any other routing protocols, simply BGP. So I also wanted to clear up some perhaps confusion that exists out there about dedicated connections versus hosted connections. So dedicated connections are where we allocate you a port on one of our routers in one of these co-location facilities. It is either a 1 gig port or a 10 gig port, and it is assigned to you. We give you a letter of authorization that allows you to connect to that port, which you then use with either the provider or with a partner. Now, in the hosted connection model, what we do here is we actually provide connections to our partners, actually at 1 or 10 gig or multiples, and they then divide this up into smaller amounts of bandwidths for customers. So in this case, if you wanted a connection that was perhaps 50 megabits per second, or 100, 200, all the way up to 500 megabits per second, These are hosted connections, and they're provided on these partner interconnects. When you request one of these connections from a partner, you actually go to the partner first. You don't need to come into the AWS console, and you provide that partner with your AWS account number. They then provision the connection at a defined bandwidth, and they assign the VLAN to that particular connection. Now, as a result of assigning that VLAN, we need to consider the impact on virtual interfaces. Now, a virtual interface is defined via VLAN tag and a BGP session. One of those decisions has just been made for you by the partner. So as a result, this hosted connection now only supports a single virtual interface. You can, of course, have multiple hosted connections. That's not a problem. But you just need to consider that each one of them supports a single virtual interface. So how does that work when we want to look at resilience and diversity across these connections? Well, I'm showing you 2 Direct Connect locations here. And as you can see, in every location, we have at least 2 sets of redundant hardware. Now, these are the routers that you're connecting to. These are where we allocate the ports for your connection. And these need to connect back to our AWS regions. Now, the way they do this is actually via our global backbone. So this is a diverse and resilient set of connections from each of our Direct Connect locations back to our backbone and then onward to the multiple AWS regions around the world. So you can quite simply configure 2 different connections, either in 2 different locations or in the same location if you wanted on 2 different routers, and you've got a good level of resilience there. The other option to consider is whether you actually need more bandwidth than perhaps 10 gigabits per second. And if you do, we support something called link aggregation groups. What this allows you to do is order multiple connections from us, be assigned multiple dedicated ports, but they all have to be on the same device on our side. What you can then do is combine them together into a link aggregation group and treat them as a single connection. As I say, those ports must be on the same router on our side, so this doesn't give you the resilience across multiple pieces of hardware. So you may want to consider multiple connections to either, again, multiple locations or spread them across the routers. Now, the traffic will load balance as per link aggregation groups do across these connections per flow. And you can define the minimum number of connections that must be present in the lag for it to remain available. So perhaps you have 4 connections in the lag, and you define that you always require a minimum of 2. So this does give you a level of resilience, but it's more about increasing your bandwidth, and you need to consider where these connections terminate. So what does this look like in the console? So this is the screen where you can create a lag in the AWS console, and you'll see that we actually identify the AWS device on our end of this connection. Because as I've mentioned, it's actually very important that you can choose to create new connections on the same device in order to combine them together into a lag. So you can actually go and use this screen, even if you have no intention of creating a lag. You can use this to identify whether your connections are terminated on different devices or on the same one. We automatically provision each second connection that you create onto a different device. But some customers like to validate this, and previously you could do that by raising a support case, but now you can do it by looking in the lag console. So I've mentioned virtual interfaces a couple of times, and I've said that they are defined by a VLAN and a BGP session. But the 2 types of virtual interface that we have are public and private. And there's quite an important difference here. A private virtual interface connects you to your virtual private cloud. That's the easy way to remember it. But what does it not give you access to? Well, inside your VPC, you have your VPC base address +2. That's your DNS resolver inside your VPC. That is not reachable over a private virtual interface. Equally, you can't get to the VPC gateway endpoints. So the gateway endpoints that we have for S3 and DynamoDB, you can't reach those over a private virtual interface. You can, however, reach the recently announced private link endpoints. So what does a public VIF do? Well, a public VIF connects you to the public side of the Amazon network. And it means that you can reach all of our public endpoints. So things like S3 and DynamoDB, as an example, they have public IP addresses. You often reach them over the internet. You can see those over a public VIF. We recently announced global public VIFs, and what this means is now when you create one of these virtual interfaces, we actually announce to you all of our IP addresses for the Amazon backbone globally. So between 2,000 and 3,000 prefixes at the moment, we will announce to you over that public virtual interface. So all traffic from you going to AWS will come over that connection, and vice versa. All traffic from us coming back to your IP addresses will go over that Direct Connect. And I'm going to cover a little bit later on how you can control that if that perhaps isn't the behavior that you want. So let's look at how you create this virtual interface. Now, this is the screen for creating a virtual interface. And I want to draw your attention right away to the very top of the screen. Quite often people miss this. This is where the choice is made about whether this virtual interface is public or private. So in this example, it's a private virtual interface. But quite simply, we still have to define the same things, whether it's public or private. We're going to define the VLAN that we're using for this particular virtual interface. We're going to have to define some IP addresses, one for each end of the BGP session. So in this example, this is public, so we have to define the IP addresses because for the peering session, we need to be using public IPs. For a private virtual interface, you'll see it's slightly different. And finally, at the bottom of the screen, we have the BGP configuration parameters. Now, on a public virtual interface, we actually ask you to tell us what IP addresses you plan to announce to us over this virtual interface. And this is because we now need to verify that you actually own these IP addresses or have permission from whoever does own them to announce them to us over this connection. As I mentioned, this influences our traffic flow both to and from AWS, so we want to be sure who owns these IPs. So when you fill in that field with your IP addresses, this interface will go into a state of verifying. And at that point, we will do some checks to validate who owns the IPs before it goes into a state where you can then configure your end of the connection and bring the BGP session up. So how does this differ for a private virtual interface? Well, we still have the choice at the top. Obviously, we switch it to private now. We still have the option for VLANs and IP addresses, but you'll notice there's an option now to automatically generate the IP addresses for the peering session. You can uncheck that. You can still specify your own IPs, but we assign a pair of 169 addresses just for those 2 addresses on each end of the connection. And once again, we need to configure BGP. In this case, though, you don't need to tell us what IP addresses you're going to advertise, because these are going to be limited in scope so that they only reach your VPC. Now, there is one other set of choices you have to make when you're creating a private virtual interface. And this is whether you're going to associate it with a virtual private gateway on your VPC, or are you going to associate it with the newly announced Direct Connect gateway? So this is where you make that decision. So it's quite simple. We make a choice at this point. We have to have created our Direct Connect gateway, and our Direct Connect gateway is a global object. Now, I'm going to visit this in a little bit more detail later on and how it works, but this is the stage in the process where you decide where this virtual interface is attaching. So you saw in that screen where we created the virtual interface, I was defining the IPv4 addresses for this peering session. Now, once that's created, we have the option to then add an IPv6 peering session over the same virtual interface. So we support IPv6 on Direct Connect, we support IPv6 inside the VPC, and various public services that we have are also available on IPv6. And the configuration is the same, whether it's a public virtual interface or a private virtual interface. You simply choose to add a peering session. We will assign a /125 for that peering session, and we will then accept announcements of /64s or shorter. So IPv6 fully supported on Direct Connect. So I've explained a little bit about the difference between dedicated connections and hosted connections, but how do these all fit together in terms of account structure? Well, if we take your account as the blue box at the top here, and we have the dedicated or regular connection here, this is a 1 gig or a 10 gig. It is assigned to this account. That's where you created the connection. On that connection, you're then going to create a virtual interface, and you assign it a VLAN, as we saw on those previous screens. Now, we can create multiples of these, so VLAN 101, VLAN 102. We can keep adding them, as many as we need, up to a limit of 50 on each connection. However, it's quite common that customers don't want to use the virtual interface in the account that the connection was requested in. Quite often we see networking teams have ordered the connection, but actually they want to share the virtual interface out perhaps to different organizations within the company, perhaps different business units, and this is what we call a hosted virtual interface. So when you have a connection and you create that virtual interface, there was an option to change where you use it, and you can put in another AWS account number. When you do that, it will appear in the other account, as I'm showing it here where it says your other account. You then choose in that account to accept it. When you do that, you can now attach it to your virtual private gateway in that account, or perhaps to a Direct Connect gateway that is in that account. And of course, you can keep creating more of these. So just to give the same example with hosted connections, how does that work? Well, there is an extra piece here. There is the interconnect that a partner has with us. And remember, these are the sub 1 gig connections, the 500 meg or less. So the partner has the interconnect with us. They create a hosted connection for you on their interconnect. And then you have the choice to create the virtual interface on it. But remember that VLAN was defined on the hosted connection. So it is already defined by the time you get to the virtual interface. And you see this in the console because the VLAN field will be grayed out. If you want to then have an additional virtual interface, as I mentioned earlier, you simply request an additional hosted connection, define the bandwidth, and create another virtual interface on it. So that's the difference between the two and how you can create hosted virtual interfaces. And just to be clear, you can create hosted virtual interfaces with these hosted connections. So you can share this again to another account. That virtual interface does not need to be in the same account that you have the connection. So how do we monitor Direct Connect? Well, there's a whole bunch of CloudWatch metrics that we now publish for Direct Connect. We obviously have the connection state, so just like the VPN, you can create alarms based on whether we see the connection as up or down. We're then giving you various metrics around data transfer, around potential error count, and on 10 gig connections, we also provide you with visibility of the light levels that we're seeing on the interfaces. So these are really useful for monitoring and diagnosing potential problems you might be having with your Direct Connect connection. So what about the billing side of things on Direct Connect? Well, actually, in a very similar way to the VPN connection, we charge for the port hours. So when a connection is created, we understand that it might take some time for you to arrange a cross-connect, to perhaps get your partner to deliver a connection either into a data center or into one of our locations. So the port hours start being charged when that connection comes up for the first time or 90 days has expired. And as you get closer to 90 days, you'll start receiving emails from us reminding you that this connection exists and that you're going to start being charged or that the connection should be deleted. Once you have a Direct Connect up and running and you have a virtual interface in place, then you benefit from those reduced data transfer charges I talked about. If you are running a VPN over the top of a public virtual interface, because remember, it's all of our public IPs that are available on a public virtual interface, you can establish an IPsec VPN to our endpoints over the top of it. The VPN data transfer cost is actually charged at the Direct Connect rate, so the lower rate. Also, to be clear, the data transfer is charged to the account that has the virtual interface. So if you've created a private virtual interface, shared it to another account, perhaps a business unit with a production VPC, that's where you're going to see the data transfer charges, not in the account that owns the connection. The connection account will see the port hour fee. So on a public virtual interface, though, there's a couple of different scenarios. If you're accessing resources that you own over this public virtual interface, so perhaps an S3 bucket with some assets in it, you download those, you're going to be paying for the data transfer, and you're going to pay at the reduced Direct Connect rate. However, if it's another account, but it's within your organization or your consolidated billing family, then again, you benefit from the reduced data transfer rate. But you're going to pay for that data transfer because you own the resource that you're accessing. But if you access someone else's resource, so perhaps you access my S3 bucket, then actually you don't pay for that data transfer. I'm the one that pays for that data transfer. So BGP is clearly a very important piece of Direct Connect. So just a quick reminder, what is BGP? Well, BGP runs on port 179 across this virtual interface, across that VLAN that we've defined. BGP neighbors on each end of the connection exchange routing information. And in terms of what paths we prefer, this is the start of making that decision. We will always prefer the most specific path that we have to an IP address. We use AS numbers to identify each end of the connection. And in our case, we use eBGP. And that's because the AS numbers on each end of the connection will differ. The AS path is actually used as a measure of distance. So if we're making decisions based on the shortest path to get to a destination over Direct Connect, then we're going to look for the shortest AS path. And in terms of local preference, this is something that you apply on your end of Direct Connect. So it's how you configure your routers to make a decision of which path to use to send traffic to AWS. And there's nothing that says the traffic has to be symmetrical. Best practice says it probably will be, but you can choose to send traffic to us over one connection, and we might return it over another path if that's what you've influenced us to do. So a little bit more detail on public virtual interfaces. It gives you access to those public IPs on the Amazon side that I've mentioned. It does require public IP addresses for the BGP session. You remember on the screen where we created the virtual interface, there was not the option to auto-generate IPs for a public VIF. If you don't have public IP addresses that you can assign to that peering session, that's not a problem. Just raise an AWS support case. We will assign you a /31 that you can use for that peering session, so 2 IP addresses. If you choose to use a public AS number for your end of this session, you must own it. And again, we will validate that on a public virtual interface. If you use a private AS number, that's absolutely fine as well. But there is a slight difference in behavior here. If you use a private AS number, you won't be able to do AS prepending to influence our traffic decisions if you have multiple connections. Whereas if you are using a public virtual interface, you can do AS prepending. And finally, global prefixes is now the default on a public virtual interface. If you created a public virtual interface before the beginning of November, you will have been receiving the prefixes just for the region that your connection goes to, and we haven't changed that. Any newly created public virtual interfaces, you will receive the full Amazon route table for the whole of our backbone. If you want to update the virtual interface that you already have, where you're only receiving the local region prefixes, again, just open a support case, we can change that. You'll see a slight interruption in your BGP session when it drops and reestablishes, but then you'll receive the 2,000 to 3,000 prefixes I mentioned earlier. So this influences traffic coming and going to all of our AWS regions globally. And if you've got multiple Direct Connect connections with multiple public virtual interfaces, you might not want that. You might want to be able to influence where the traffic flows. So a couple of things to consider. Let's talk about BGP communities and AS paths. So the first thing is, every prefix that we announce to you will have a minimum of 3 hops on the AS path. So you can see here, we've got 7224, 7224, 16509. So we do that, and that's because it gives us the ability to limit any unintended propagation of our prefixes to the internet, shall we say. We also attach the no export community. So again, this should prevent any of your routers accidentally announcing the Amazon prefixes out to the rest of the internet. Both of these are documented in our routing policy, which is linked to from the Direct Connect documentation. But we also do now support a couple of other communities. So if you want to announce prefixes to us, and you only want them to be used within the local AWS region, you can attach a community of 7224, 9100. At which point we will contain that announcement and only use it within the local region. So if we have traffic flowing back to you, say, from a completely different region on the other side of the world, it'll come back to you over the internet, unless you have another Direct Connect connection, where again, you've chosen to limit the range. If you actually want to accept that these prefixes are going to be advertised to all of the AWS regions within a particular continent, that's fine. You can attach a community which is 7224, 9200. So now we'll contain it, if we look at Europe, for example, it will be contained to EU West 1, EU West 2, and EU Central 1. And then finally, if you're actually quite happy for your prefixes to be propagated globally, that's fine. You can put a 7224, 9300, and we will then propagate them to all of our regions, and that's the default. So what about the other way around? You're receiving these 2,000 to 3,000 prefixes from us. What if you don't want to receive anything perhaps outside the local region or the local continent? Well, in a very similar way, we're still going to announce them to you, but we attach these communities to each of those prefixes. So you've got 8100 showing that it came from the local region, 8200 from the continent, and if there are no communities other than the no export, it's coming from somewhere else on the backbone. So let's look at an example of this. I actually looked up an IP address here for S3 that was in the EU West 1 Ireland region. And you can see here that we've got both the 8100 and the 8200 because the local region is within the local continent. So you've got both communities attached. Now this is for a Direct Connect that is actually associated with the EU West 1 Ireland region. So this is exactly what we'd expect to see. If we perhaps look at the prefix that includes S3 for the Frankfurt region, EU Central 1, in this case, you can see that we've dropped one of those communities. So now we're just showing the 8200 community. And then finally, I looked up the IP address for S3 in our region in Canada, and you can see now the only community that we're attaching is the no export one. So you can now build route maps and policies on your router to decide whether you want to install those routes into your route table or not. So let's switch back over to the AWS side of things. Let's look at the VPC, and how does routing actually work inside your VPC? Or more accurately, how does it work inside the virtual private gateway? So here we have a VPC. It is 10.3. It is in the EU West 1 region. And we have a virtual private gateway attached back to a corporate network with a BGP session. What we're actually doing here over the corporate network is we're announcing a default route. And that's because perhaps we have many hundreds of prefixes internally, many more than we accept. We have a max prefixes limit of 100 on a private virtual interface. So in this case, the organization has decided to announce a default route. Now, you'll notice here that we've defined the Amazon side AS number. And this is where we do it. We do it when we're creating the virtual private gateway. So you can now define that exactly the same as you could on VPN, on Direct Connect, because it is a property of the virtual private gateway itself. And that is used by both a VPN connection and Direct Connect private virtual interfaces. So in our VPC, we possibly also have an internet gateway, which also typically would be a default route. So we have two ways of leaving our VPC, both of which effectively have a default route. But the decision is actually made in the route tables inside the VPC as to which one we're going to use. So here is our main route table that got created when we created this VPC, and it has a local entry in there that shows you can reach all of the IP addresses local to 10.3. Typically, you would go and add a route to that route table that says 0/0 is going out to the internet gateway, so all traffic flows out to the internet. But what about that traffic back to the corporate network? Well, although we're announcing a default route to the virtual private gateway, we don't actually have to use that inside the VPC. We can actually just create a static entry if we want to, and put a 10/8 entry in there, route it to the virtual private gateway, which then has a default route back to the corporate network. So there are actually two different routing decisions that happen here, and you can define those static routes if you need to within your VPC. So quite a common example here would be to create entries for the RFC 1918 ranges, so 10/8, the 172.16, the 192.168, and just point those at your virtual private gateway, and then simply announce a default route over Direct Connect in this case. The other option you have, though, is if you are announcing a specific set of prefixes, and it is less than 100, then you can check an option on that route table that says propagate everything that the virtual private gateway knows into the route table inside the VPC. So at this point, you don't need to maintain that route table. So with all of these possible connection options to the virtual private gateway, we've got VPNs, potentially multiple VPNs. We've got private virtual interfaces, potentially multiple private virtual interfaces. How do we decide where to send the traffic? Well, right at the top of the list, when we're evaluating the destination for this traffic, we first of all look and see, is this destined for an IP address within the VPC range? If it is, we're going to deliver it to the VPC. You cannot override that local route inside the VPC. Now, if we need to identify out of many paths which one is the best option, can we see a much better prefix match before anything else? And if so, we're going to choose that. So even if you announce a more specific range of IPs, perhaps over a VPN, compared to Direct Connect, typically we would prefer Direct Connect, but because you announce more specific prefixes via VPN, we'll actually send that traffic over the VPN. So the longest prefix match comes right up there at the top. We then look at the route tables you created in your VPC, and if you have any static route table entries, we're going to prefer those over anything that has been propagated dynamically. And if we then have dynamic routes that have been received from the virtual private gateway, we start working through another set of decisions. So we look at the Direct Connect routes first. These are going to be received over BGP. If we have multiple options, do we see a shorter AS path length on one of them? If so, we're going to choose that. If we've reached this point where we now have multiple paths to the same prefix, the AS path length is the same, this is when we're going to start balancing the traffic per flow. So we're going to be doing ECMP. If this wasn't Direct Connect, and actually it was a VPN connection, we're next going to prefer VPN static routes, so static VPN connections, and then finally, dynamic VPNs. And if we still have to break a tie in options here, then again, we look for the shortest AS path length. So this is the process we go through when we're making a decision about routing out of a VPC. So now let's have a look at Direct Connect Gateway. So this was a very recent announcement. And the key thing to remember is that Direct Connect Gateway works with private virtual interfaces. Public virtual interfaces we've already covered. They allow you to reach the global public IPs. Direct Connect Gateway is all about private virtual interfaces. And the first thing to remember is that you can attach multiple private virtual interfaces to a Direct Connect Gateway. It is a new global object that we have created, and you can actually attach these virtual interfaces from any of our Direct Connect locations. So if you have a connection perhaps in Europe to one of our colo providers there, or perhaps to another colo provider in the US, you can attach a virtual interface on both of those connections to the same Direct Connect gateway. You can then also attach the other side of that Direct Connect gateway to the virtual private gateways on your VPCs. And again, these can also be in any region, with the exception of China. So you can now use this Direct Connect gateway to provide connectivity from any Direct Connect location to any VPC in any region. You're no longer tied to having a particular Direct Connect location associated with one particular region. And the virtual private gateways and the virtual interfaces that you attach to this Direct Connect gateway, all of those must be within the same AWS account. So let's look at that a little bit more visually. So this is a typical connection with a private virtual interface. We have the Direct Connect location. I used the Las Vegas POP here at the SuperNAP. And we have the connection that goes to a private virtual interface and into our virtual private gateway. The BGP session is effectively established with the virtual private gateway, and 10.3 is announced. And from the corporate side, we have 192.168. Direct Connect gateway sits in between this. So we create a virtual interface attachment from the private virtual interface onto the Direct Connect gateway, and then we create an association between the virtual private gateway and the Direct Connect gateway. So it now sits in the middle, and actually what you see from a BGP perspective is that 10.3 is now still being announced to you. There's no difference to the previous configuration. But that's because we have a single VPC, and it's actually still in the same home region for the Las Vegas Direct Connect POP. Where this gets interesting is when we then add another virtual private cloud. So here's our VPC. We've got another virtual private gateway on that, and we choose to associate that virtual private gateway with the Direct Connect gateway. So what you now see from a BGP perspective over that single virtual interface is actually two announcements. You see the 10.3 that is coming from US West 2, but you also see 10.4. And this is coming from a VPC that is actually running in Frankfurt in EU Central 1. So it combines those together over that single virtual interface. We can go one step further. We can actually create another private virtual interface, perhaps via the Frankfurt location. You know, this might be an example of an organization such as yourselves where you actually have a presence in the US and a presence in Europe. Each of those business entities perhaps has created VPCs in your local AWS region, and traditionally you just had a Direct Connect to your local region. Well, you could now combine those together at a Direct Connect gateway and benefit from being able to send your traffic across the AWS backbone between those regions. Now, if you do this, you also might want to consider that what if you've actually got your own network on the right-hand side, linking your data centers, your offices together? Well, then you can actually choose to manipulate the routes that you announce to us. So in this case, I'm showing that the offices are 192.168.1 and .2, but actually both locations are also advertising 192.168/16. And in this case, that means that traffic going to any of the other sites on your network could go down either one of these Direct Connect virtual interfaces. So this is standard BGP. You can control the routing however you see fit for your particular network. So what does this look like in the console when you're creating a Direct Connect gateway? So first of all, the Direct Connect gateway itself is basically a definition of the AS number for our end of the connection. When you first create it, that's all you need to specify, along with a name. But once you've done that, you then choose to associate the virtual interfaces with the Direct Connect gateway. So you switch to each region in turn, you create the private virtual interface, and you remember we saw earlier that you can choose either the virtual private gateway or the Direct Connect gateway. When you do that, it creates these attachments that you see on the screen here. So I'm showing 4 virtual interfaces here attached from various different regions. The next step is then to associate those virtual private gateways from all your VPCs with the same Direct Connect gateway. And at that point, BGP will come up, and you will see the prefixes for those VPCs being announced to you over whichever virtual interfaces you've chosen to attach. Now, there's a few rules that go with Direct Connect Gateway. So first of all, the VPCs that you connect to, they can't have overlapping CIDR ranges. Now, if we send traffic to the Direct Connect Gateway, it needs to know exactly which VPC that traffic is destined for. Virtual interfaces are not related to Direct Connect Gateway. As I say, they give you access to our public prefixes. You don't associate public virtual interfaces with Direct Connect gateways. If you're going to attach a virtual private gateway to a Direct Connect gateway, it must already be attached to a VPC. So you can't do this with a detached VGW. You can't connect to our region in China. And also, you can't use Direct Connect Gateway to connect to a VPC in a different account. So let's look at the traffic flows. This is the same diagram we had earlier. I removed the VPCs from it. But this traffic flow is absolutely fine. We're sending traffic from the left-hand side to the right or vice versa, from a virtual interface to a virtual private gateway. What you can't do is use this to send traffic between two different VPCs. But now we have inter-region peering, you wouldn't need to do this anyway. If you've also got a VPN connection that is associated with one of those virtual private gateways, Direct Connect Gateway does not allow you to route to that either. And equally, on the other side of the diagram, you can't use Direct Connect Gateway in the same way that you can use CloudHub. So it doesn't allow you to route traffic between two of your locations. So traffic flowing effectively from east to west across that diagram, that is the defined traffic flow for a Direct Connect Gateway. So now let's revisit pricing on Direct Connect, because things have changed a little bit. We've now got multiple Direct Connect locations connecting to multiple regions using the Direct Connect Gateway. So we now need to consider two factors when we're trying to work out how much this data transfer is going to cost. So we need to consider the region and the Direct Connect location. So going back to the diagram, I've simplified things a little bit. I've taken one of the virtual interfaces away, and we're looking at the Direct Connect location that is here in Las Vegas, and it is connecting to two VPCs in two different regions, one in US West 2, one in EU Central 1. Now, this is the Direct Connect pricing page. A little bit of an eye test, I realize. I've highlighted the row that's relevant here, so let's zoom in a little bit onto that. And what you can see here is we've got the Direct Connect location in the left-hand column, and then at the top, we've got the various geographic regions where we have the AWS regions we're connecting to. So in this case, we're connecting to US West Oregon, and we're connecting to EU Central Frankfurt. So in this case, it's 2 cents and 2.8 cents per gig. So that's how to interpret the pricing page now for Direct Connect. You need to look up the location and the regions that you're connecting to, and where they meet, that's the price you pay for data transfer across the Direct Connect gateway. So how does VPN and Direct Connect work with our other AWS services? So that public VIF, it allows you to connect to those public AWS services. You can see any AWS region. You can see all of our services in those regions that are exposed on public IP addresses. You can also see anyone else who is using AWS in those regions on their public IPs. So if someone has launched an EC2 instance and assigned it an Elastic IP address, that's an Amazon public IP. You can see that over Direct Connect. You can also see those managed VPN endpoints that we talked about earlier. So this is how you build an IPsec VPN over the top of Direct Connect. In terms of the services that you might access, the ones on the left, perhaps they occurred to you. Things like Amazon S3, that has a public IP address, DynamoDB. But there's also some other services that you might not have thought about. So Amazon Workspaces. When you connect using the Workspaces client, that connects to a broker on a public IP address. So you use a public virtual interface to be able to connect into your workspace if you want to. AWS Lambda, it can exist both outside and inside your VPC. ELB, again, you have external Elastic load balancers. So therefore, you could connect to that over a public virtual interface. If we look at it from the private virtual interface perspective, remember you can't connect to the VPC DNS server, the +2 address, and you can't connect to those gateway endpoints. But again, workspaces, when you create a workspace, it has a network interface that is inside your VPC. So if that workspace needs to perhaps reach back to your corporate network, perhaps to your environments, some file shares, etc., that's where you would use a private virtual interface. Again, Lambda exists inside your VPC, can exist inside your VPC, EC2, ELB. So you need to just consider which services you're using, and therefore whether you need a public virtual interface, private virtual interfaces, or a combination of both. So again, things like directory services, which works with workspaces, again, that also needs to reach back to your on-premises environment. You would use a private virtual interface for that. RDS, perhaps you're needing to access RDS from your on-premises network. This is all where a private virtual interface fits, and obviously, perhaps with Direct Connect Gateway as well. So I hope that gives you a bit of an insight into some of the new features we've added to both Direct Connect and VPN over the last 12 months. If you're not aware, I wanted to mention the Certified Advanced Networking specialty that we now have. So these are for people who design, develop, and deploy cloud-based solutions using AWS, but with a very specific networking focus. If you're interested in this and you have an associate level certification already, then perhaps you might want to go and take this. You can do this on site here at reInvent. Also, I wanted to mention that we will have a study guide available in early 2018 that myself and a bunch of people involved in the networking track here at reInvent this year have been involved in writing. So hopefully this will act as a good resource and a reference for you to use when working with networking on AWS. So with that, we've got a few minutes left. If anyone's got any questions, I'm happy to take them, perhaps down at the side of the stage. But thank you very much for coming to the session, and please fill out your evaluations.